The case against highly conductive ESD flooring. NFPA 99 no longer covers conductive flooring. You may have heard ESD flooring manufacturers refer to a standard called NFPA 99. With roots dating back to the 1950s, NFPA 99 guides healthcare services in minimising the hazards of fire, explosion and electricity in their facilities. In 2015, the NFPA removed conductive flooring from the standard. But let's forget for a moment that for ESD flooring, NFPA 99 is defunct. To meet the NFPA standard, the electrical resistance of an ESD floor had to measure no less than 2.5 times 10 to the 4th, or 25,000 ohms. The resistance test for NFPA 99 is similar to ANSI/ESD standard test method STM 7.1. Both tests measure electrical resistance, or a floor's capacity to resist or reduce electrical current. Neither test reliably simulates a real-world environment. Both use a battery-operated generator to apply voltage across the surface of the flooring material. Battery-operated generators put out direct or DC current, which flows in one direction. The electricity in common power circuits travels in waves, or AC, alternating current, which periodically changes or reverses direction. An independent engineering lab tested the resistance of ESD floors using both AC and DC currents. Delivered across an ESD floor, AC currents measured as much as 9 times higher than predicted by theoretical calculations based on Ohm's law. This means in a real-world environment, electricity will flow across the floor far faster than predicted mathematically. That's why when selecting any ESD floor, it's crucial to consider safety. It's also why the FAA in FAA 019E prohibits conductive flooring that measures under 1 times 10 to the 6th, any place where personnel may come into contact with energised equipment. In layman's terms, anywhere electronics are plugged into an outlet. While NFPA 99 and ANSI/ESD 7.1 were similar tests, they differed in one very important way. The tests for NFPA 99 were done with 500 volts of electricity. ESD 7.1 is done with only 10 volts. 10! That's 1/50th the voltage used in NFPA 99. Why does it matter? Because some people assume the readings are interchangeable, and they're not. According to Ohm's law, voltage correlates inversely to electrical resistance. Put simply, less applied voltage yields a higher resistance reading, and vice versa. The NFPA considers a resistance of 25,000 ohms, 2.5 times 10 to the 4th, safe if the floor is tested at 500 volts. Tested at 10 volts, the same floor would likely measure over 1 times 10 to the 5th, or 100,000 ohms. Both resistance measurements are considered safe for applications where energised equipment is in use, based on their test methods. Now consider the reverse. More applied voltage yields lower resistance readings. Suppose at 10 volts per ESD 7.1, a floor measures 25,000 ohms. At 500 volts, the same floor could measure as low as 2,500 ohms, a resistance so dangerously low that electricity would rocket across its surface at a rate lethal to humans. If someone standing or kneeling on an overly conductive floor were to accidentally become part of a live electrical circuit, while servicing or inspecting electrified equipment for example, he or she could receive a dangerous electrical shock. If a manufacturer claims their highly conductive floor meets the defunct NFPA 99 standard, be sure to ask how the floor was tested and exactly how much voltage was applied. StaticWorks produces static control flooring products that protect sensitive electronic components from harm caused by electrostatic discharge, ESD. To learn more about preventing static electricity, give us a call or visit our website. StaticWorks. We keep you grounded.